Hey there, this is MathCamp321 presenting the solution to question number 18 of the PARCC Algebra 2 practice test. This question asks, consider the functions f of x and g of x described by the equations, and also consider the functions h of x and k of x whose graphs are shown below. Then they go on to ask a series of questions about the graph's symmetry. Now, I personally feel like symmetry questions are easiest to tackle if the graphs are right in front of you. And they give us the graphs for two of the functions, but not for the first two. So this is a graphing calculator question, and I'm going to suggest that we get the graphs for f of x and for g of x. If you need to use your calculator, that's fine, but if you can quickly do a sketch just based on your knowledge of these functions, that's also good too, and it might save you a little bit of time by not having to reach for the calculator. So let's start by drawing the graph of f of x equals 3x squared. This is a quadratic function, and the graph of a quadratic function looks like a parabola. This particular parabola will open upward, and its vertex will be at 0, 0. The second function that they discuss is g of x equals negative x cubed plus 5. Now the graph of x cubed looks like what I call a wiggle, but this particular wiggle has been turned upside down because of this negative that's out in front. It's also been shifted 5 units up because of this plus 5 on the outside. So I'm going to draw a picture of what looks like a wiggle that's been flipped upside down and shifted 5 units upward. When I draw a wiggle, I think of it as having two arms. The first arm is going to open upward and to the left, and the second arm is going to open downward and to the right. Okay, so now we have the graphs of all four functions. What I want to do now is quickly just address what it means for a function to be even or odd. Let's start with even. A function is even if it exhibits y-axis symmetry. That is to say, if you were to fold the graph along the y-axis, the left and the right sides would line up. So let's very quickly go through our four graphs and see if they're even. Let's start with f of x. If I were to fold along the y-axis, would the left and right sides line up? I think the answer is yes. I think that f of x is an even function, so I'm going to go ahead and write down even. Now let's go to g of x. If I were to flip or fold along the y-axis here, and I'll draw that y-axis in for you. If I were to fold over the y-axis, would the right and the left sides match up? And I think the answer to that is no. This graph is not even. Let's now go to h of x. If we look at the graph of h of x, this is some sort of manipulated trig function. If you look real quick, it actually looks like a mustache. If I were to fold that mustache-looking graph over the y-axis, would the left and the right sides of the mustache line up? And I think the answer would be yes. This graph is too even. And finally, let's consider the graph of k of x. This looks to me like it's a sine graph. If I were to fold along the y-axis, would the left and the right sides line up exactly? And the answer is no. So of our four functions, two of them were even. Now let's do a quick review of what it means for a function to be odd. Odd means symmetry over the origin. Now, symmetry over the origin I think is a little bit more challenging for students to understand, but the easiest way that I like to think about symmetry over the origin is if I have a graph and I turn the paper completely upside down, does the graph look exactly the same as it did when right side up? If that condition is met, then we can call the function odd. So let's toggle through each of the four graphs and see which ones, if any, are odd. Let's start with the blue graph, f of x, this parabola. If you were to turn your paper upside down, would this right side up parabola look exactly the same as if I were to turn the paper upside down? The answer is no. This is not an odd function. Let's take a look at g of x. If I were to take this image and turn it completely upside down, would it look exactly the same as it does right side up? Now this one's tempting, but if I turn this upside down, then this point is at 0, 5. But if I turn the paper upside down, it's going to be at 0, -5. So this is not odd either. Now let's take a look at h of x. If I take this mustache-looking graph and I turn it completely upside down, will it still look like that same mustache? And the answer to that is no. It'll be an upside-down mustache, so that's not going to work. Now if I go to k of x, which is this sine graph, and if I were to turn this upside down, it would look exactly the same as it does right side up. So this is our one and only odd graph. So I'm going to write down the word odd. Now let's, as quickly as we can, go through our answer choices and pick the ones which meet the condition. There could be more than one answer. A, f is an odd function. Well, we already discussed that, and we said f is even only, so that does not work. Choice B, f is neither an even nor odd function. Well, that doesn't work either because we said f was even. Choice C, g is an even function. Well, we don't have anything written next to g. G is neither even nor odd. Letter D, g is neither even nor odd. Well, that's true. It has nothing written next to it. We didn't classify it as either even or odd, so it's neither even nor odd. Letter E, h is an even function. Yes, we classify that as even, so that one works. F, h is an odd function. We only made one classification for h, and we said that it was even. It is not odd. That does not work. Letter G, k is an odd function. Yes, we said that k was an odd function, so that is a answer choice. And then finally h, k is neither even nor odd. Well, that doesn't work because we said k was odd, so it can't be neither of them, so that does not work. So it seems to me that 3 of the answers worked, and those answers were D, E, and G.